Today we are going to start a new topic called as generating function of Legendre's polynomial. Before that, we'll just take a recap what we have did in the previous lectures. So we have determined the general solution of Legendre's equation. Then this is a general solution of a Legendre equation. Then this is the Rodriguez formula, so which has been denoted like this. And then we have derived the Legendre's polynomial. We have derived the Legendre's polynomial till the value of n is equals to 6. Then we have solved the orthogonality of Legendre's polynomial. So here we have proved that this value is equals to 0. So as I said at the start, we are going to start a new topic called as the generating functions of Legendre's polynomial. Sorry. So this is just a question answers format I have written. So most of the time during the examination it's being asked like this also. So these are the three different ways of asking the same question. So first is prove that the Legendre's polynomial Pn of x so is the coefficients of h raised to n l in 1 into bracket 1 minus 2x of h plus n h the whole square into whole minus 1 upon 2 sorry. Then also prove that Pn of x is the coefficients of z or z of n in the expansion of 1 minus 2x of z plus z square whole raised to minus 1 upon 2. So it could be somewhere, it could be square root also in ascending powers of z. Okay, so in these three ways this question could be asked. So as I mentioned, so this is a proof. So this is a 4-step proofs. First we'll just write this expression. So actually based on this question I'll solve. So I'll use the coefficients as z. I'm not going to use my coefficients as h. So if during the examination if you're getting it as h, so please replace z with h. Okay, so let's start my proof. So first step, 1 minus 2xz plus z square raised to minus 1 upon 2 which is equals to 1 minus z bracket 2x minus z bracket raised to minus 1 upon 2. This thing can also be written as 1 plus 1 upon 2z in the bracket 2x minus z plus minus 1 upon 2. Actually I'm writing all the numerator part first into minus 3 upon 2 divided by 2 factorial, okay, into z square into 2x minus z the whole square plus, now once again numerator, minus 1 by 2 minus 3 by 2 minus 5 by 2 goes ahead, then again minus 1 by 2 minus n plus 1 divided by n factorial minus z of n into one more term is there, that is 2x minus z of n, then plus higher powers that I'm not going to write, so I'll simply write dot dot dot. Let me mark this as equation number 1. Okay, so I have written this and then I have solved up till here, and this I have marked it as equation number 1. Okay, now this is my, as I said, so let me mark this as my step. As I said, this is 4-step process. So this is my step 1. Don't mark. This is just for the explanation purpose. Step 1. Okay. Now let me start with step 2. So my step 2 is coefficient of z of n. Where is that z of n? This. Okay. So step 2. So what I'll do? So I'll use some other pen. Green. So minus 1 upon 2, minus 3 upon 2, then minus 5 by 2, dot 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 dot. It goes with minus 1 upon 2, minus n plus 1 raised to minus 1 raised to n, then 2 raised to 2 of x raised to n divided by n factorial. Else I can write all these terms as equals to 1.3.5 into 2n minus 1 2 of n into x of n, which is divided by 2 raised to n into n factorial, which is further equals to this 2 and 2 n get cancels. As a result, what we will get is 1 into 5 into 2n minus 1 minus 1. So this is dot 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 means it higher powers x raised to n divided by n factorial. So actually this I should write it as now coefficient of z of n in. So now the coefficient of z of n in this form. So I have substituted the value of n as n only. In the next step, what I will substitute? I'll substitute the value of n as n minus 1. That will be my step 3. And step 4 it will be, I'll substitute the value of n as n minus 2. This way we will substitute. Okay. So now this is my step 2. Now let's switch to step 3. That was page number 13. Now this is page number 14. So here again, that is coefficient of z of n in. So this is step number 2. So this is step number 3. Or you can see I've just divided into steps. So it's not mandatory that this should be this step and this should be that step. This is just the distribution which I have done. Okay, so coefficient of this. So again same thing, minus 1 upon 2, then minus 3 by 2, minus 5 by 2, dot 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 dot, higher powers minus 1 upon 2, minus n plus 2. It was 1, so it became plus 2 because we had previously 1. Then and I'll have minus z which is n minus 1, and it is 2x minus z which will be n minus 1. So now as I mentioned in the previous step, we have substituted the value of n as n. Now it is n minus 1 divided by n minus 1 factorial. Okay, so now how it will be? It will be again minus 1 by 2, minus 3 by 2, minus 5 by 2, dot dot dot, higher powers minus 1 upon 2, minus plus 2, then minus 1 and minus 1, then in the bracket again this we have to do the substitution. So it will be minus 1 minus of this into 2x raised to n minus 2 whole divided by n minus 1 factorial, which further you will be getting as 1 into 3 into 5 dot 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 2n minus 3 with 2n minus 2 divided by n minus 1 x raised to n minus 1 divided by 2 raised to n minus 1 n minus 1 factorial. Else you can write this as 1 3 5 2n minus 3 n minus 1 x raised to n minus 2. So you will be getting value as 2 here and n minus 1 this n minus 1 factorial. Again next step it will be 1 dot 3 dot 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 2n minus 3 then divided by 2 of n minus 1 factorial into 2n minus 1 divided by 2n minus 1 into n minus 1 into x of n minus 2, which is giving me further substitutions as for the values as 3 into 1 1 into 3 into 5 with 2n minus 3 this term, 2n minus 1 that term, then into n of n minus 1 n of n minus 1 and below it will be n factorial with this term with it will be 2 of 2n minus 1 into x of n minus 2. Okay, now this is a solution which we are getting it for our coefficient. Now next, as I told you, step number 4 with my coefficient values, coefficient of Zn in. Okay, so as mentioned above, this is my step number, my distributed step for coefficient of Zn, where the value of n I'll substitute as n minus 2. Again same terms, minus 1 upon 2 minus 3 by 2 minus 5 by 2 dot 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 minus 1 by 2 minus n plus 3 divided by n minus 2 factorial z of n minus 2 into 2x minus z n minus 2. Okay, so next step it will be minus 1 by 2 then minus 3 by 2 minus 5 by 2 dot 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 minus 1 by 2 minus n plus 3 into minus 1 raised to n minus 2 divided by n minus 2 factorial multiplied by, this term is multiplied with n minus 2, this will give me n minus 2, n minus this term n minus 3 divided by 2 factorial into 2x raised to n minus 4, which you can write it as further as 1.3.5 dot 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 2n minus 5 into 2n minus 2 into n minus 2 factorial into n minus 2 n minus 3 into 2 factorial into 2x raised to n minus 4. Okay, so which further I'll get it as 1 into 3 into 5 further higher powers 2n minus 5 into 2n minus 3 into 2n minus 1. Further multiplications are there, okay? Divided by 4n minus 2 factorial into, it is n minus 2 divided by 2 of 2n minus 3 into, I'll write it here only then. I'll write it down, into n minus 3 divided by 2n minus 1 into x raised to n minus 4. I hope up till here it is clear how we have solved this one. Okay. Now next step it is which is equals to 1.3.5 2n minus 1 divided by 4 of n into n minus 1 into n minus 2 factorial into n of n minus 1 into n minus 2 into n minus 3 divided by 2 of 2n minus 3 into 2n minus 1 into whole into, it will be x raised to n minus 4. Next step it will be 1 into 3 into 5 in dot 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 dot, it is 2n minus 1 divided by n factorial, this will be n factorial into n of n minus 1, n minus 2, then again n minus 3 divided by, this is multiplication of this, n minus 3 divided by 2 into 4, this 4 we are bringing it here, into 2n minus 1 and 2n minus 3 into, again its into sign is x raised to n minus 4 or and so on. So we are having more powers of this. So thus what we can write it as is the coefficient of z of n in the expansion of 1. Okay, so all the coefficients which we have got till now, so we will add it into this. So what we will get it is equals to is equals to 1 into 3 into 5 2 of n minus 1 divided by n factorial into x raised to n minus n of n minus 1 upon 2 of 2n minus 1 2n minus 1 plus n of n minus 1 into n minus 2 n minus 2 multiplied by, so again multiplied by that term, so this term I'll write it down here, plus it will be n of n minus 1 into n minus 3 divided by 2 into 4 into 2n minus 1 2n minus 3 into x raised to n minus 4. Okay, n minus 4 plus higher powers. Okay, so which is nothing but Pn of x. So does what we are getting, does coefficients of z square, z cube, etc. in 1 are there p1 of x, then p2 of x, then p3 of x dot 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 dot. So thus we have written so hence 1 minus 2x z plus z square raised to minus 1 upon 2 is equals to, it is equals to p naught of x plus z of p1 of x plus z square of p2 of x plus z cube of p3 of x dot 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 plus zn of pn of x plus dot 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 dot. So which we are giving, which I am getting it as what, 1 minus 2xz plus z square raised to minus 1 upon 2, which is equals to summation of n is equals to 0 to n is equals to infinity. So pn of x into z of n. So as a result we have proved our proof. So as I mentioned at the start also, we have divided this proof into 4 steps. Okay, so at the start we had this step number 1, we have simply written this, then the coefficients of z of n, then the where the value of n we have substituted as n only. Here in the step number 3, the value of n we have substituted as n minus 1, and in the step number 4 the value of n was n minus 2, and as a result we have substitute solved this further and we have got the solution. Okay, so thanks for watching.